First of all, look at all the numbers. Are they all on the same place of your powers chart? In the same column? 2, is 8 in your column with 2? Yes, it is. So I think we want to change everything to 2s. The second thing is, do you remember how to change a radical to an exponent? Ooh, that's great. 10 exponent laws. What do we do with the cube root? It's the same as the power of 1/3. So I have 2 to the x on the left. The 8 I can change to 2 cubed. The cube root of 2 I can change to 2 to the 1/3. What's your exponent law for multiplying if the bases are the same? If I make it easy, 3 squared times 3 cubed is 3 to the 5. And again, if you forget, 3 squared means 3 times 3. 3 cubed means 3 times 3 times 3. How many 3's do I have multiplied together there? Obviously, there's 5 of them. And we add the exponents together. So it works here, now that we've got not as nice numbers, I have to add exponents. How do you add fractions? It'd be a common denominator. Are you okay that I do 9/3 plus 1/3 and just write 10/3 here? And this is our goal. Once you get a single power on both sides with the same base. So, what could x possibly be? 10/3. Really easy and really straightforward. But we have to know our exponent laws to get there. Okay, B. 125 and 625. Are those in the same column on your powers chart? Did we go that high? I think we went up to 625 for 5, right? So this will be, okay, square root of 5 cubed. I'm going to take this slowly. If you want to do it quicker, you could. And then I have the cube root, and this will be 5 to the 4th. What can you do with the square root? The square root will be an exponent of a half. Cube root will be an exponent of a third. Exponent to an exponent is you multiply. Exponent to an exponent, you multiply. I would actually be okay if you went from the 625 to the 5 to the 4/3 in one step. Because 5 to the 4 is 625 and the cube root is a third. That's easy to put together. Same thing with the 5 to the 3 halves. 125 is 5 cubed, and then you have the half. 5 to the 3 halves. Now we have another exponent to an exponent. So we have to multiply again. 3 halves times 2 is just 3. 3 halves times plus 1 will be plus 3 halves equals 2. And it is only now that you have a single power on both sides that we can go, so the 3x plus 3 halves has to equal 4/3. So I'm going to subtract 3 halves on both sides. I'm going to make my 4/3 8/6 and my 3 halves 9/6, which gives me negative 1/6. I'm going to divide both sides by 3, which is the same as multiplying by 1/3. And it's probably good we didn't guess and check on this question, because I don't think we would have come up with negative 1/18 quickly if we were guessing and checking. So all of our exponent laws from previous years will come into effect. All of your radicals, you change radicals to fractions as exponents. Then we have powers to powers, where you multiply. You have multiplying with the same base, where you add the exponents. There's dividing with the same base, you'd subtract the exponents. And we combine all of those laws until we get to this point, where we have the same base, but different exponents. But if both sides have the same base and they're equal, it makes sense that the exponents would have to be equal. So we just make the exponents equal to each other, and then it's simple math to solve from there. All right, circle questions 9 and 10. Eventually, we're going to get to questions which are calculator questions. These are all non-calculator because they're from your powers chart. Calculator questions will look like this. I'll give you an easy one to start off with. And you're allowed to guess and check with your calculator. I want to have your answer correct. We'll start off with 3 decimal places. Some of you are going to have to be guessing and checking quite quickly on your calculator. I need 3 decimal places correctly. 3 to what power is 52? I need 3 decimal places correct. And if you already know how to use the log button, it's not allowed. You're not supposed to know it yet. Yeah. Oh, and if you have a cheating method, you can a solving thing, right? That's technically a great way to do this on a graphing calculator. You could put this into y1 and this into y2 and find out where they intersect, and that'll be your solution. Some of you have solving for x programs built into your calculator. That's also really nice. But some of you are just going to have to guess what x is and see what you can get. How close can you get? Can you see that it has to be bigger than 3? Because 3 cubed is 27, but 3 to the 4 is 81. So you know it's going to be 3 point something. How close can you get? Well, now you're cheating too. I shouldn't have told you how to cheat. How close are you getting? 3.6. A little bit too much. You're getting closer. Has people found 3.6 was too much and 3.5 was not big enough? So we know it's 3.5 something. So now you can't use that, I'll give you another one. You can't cheat, you just have to guess. You can guess until you find it. You're not allowed logs. You just have to guess. Anybody think they've got the next digit? From guessing and checking? What do you think? It is a 9. All right. We're getting there. Not impossible. Yeah, those are 3 decimals correct, yes. This one is actually a 6, but it will round up to a 7. Pretty good, 114. Yeah.
Wait, what is the other method besides using long?
Well, you could use a graphing calculator or decimals. You could type this into Y1 and this into Y2, and then your 2 graphs would intersect, and that's your answer. So if you have a graphing calculator, that'd be good. If you don't have a graphing calculator, then that method doesn't work at all. Guessing and checking would take you, but then you're going to have to learn how to use logarithms, which we'll get to. Will we get there tomorrow? 5.4. Oh, and for those of you wondering the last, it is 6577, depending on how close you are wanting to get. And it keeps on going. Dot, dot, dot.
First thing, right? He's there, right? I can see. Yeah. Let me do my shit.